Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the RS-232 standard for the serial communication in 8051 microcontroller. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the detailed serial communication or the SFRs used in serial communication in 8051 microcontroller. The 8051 microcontroller supports full duplex serial communication. I hope you all remember what is meant by full duplex. Let's see once again. In full duplex communication, the transmitter and the receiver or the block A and block B can transmit and can receive data at the same time. This type of communication is known as full duplex communication. For example, the telephone line or the cell phones or the mobile phones are the example of the full duplex communication. A full duplex asynchronous serial interface can be implemented on using a serial interface control circuitry. Here, the word asynchronous means we seen there are two types of serial communication. First one is asynchronous and second one is synchronous. Here, the 8051 microcontroller supports the asynchronous communication. That means the data must be placed in the start bit and the stop bit. Okay, in the start bit and the stop bit. The start bit is always 0 and stop bit is always 1. That means in 8051 microcontroller the data is transferred with the help of start bit and stop bit. In some cases we can add the parity bits in it. Okay, I hope you all remember these things. A full duplex asynchronous serial interface can be implemented on using serial interface control circuitry. It has serial communication circuit which uses a register in SFR called as SBUF to hold the data. Here SBUF stands for the serial buffer and this SFR works to hold the specific data. The SFR register SCON is used to control the data communication. The SCON stands for the serial communication and this serial communication SFR is used to control all the data communication. Okay, and the last one is the SFR register PCON is used along with the timer 1 to control the data rates. The PCON stands for power control register and it is used to control the data rates. Let's see details about each register one by one. The first one is SBUF register. We know that SBUF register stands for the serial buffer register. The SBUF is an 8-bit register used for the serial communication. For a byte data to be transmitted via T cross D line, it must be placed in the SBUF register. The moment the byte is written into the SBUF, it is framed with the start and stop bits and transferred via T cross D line. That means whatever data we want to transmit from the controller, we have to place first in the SBUF register. Okay. SBUF holds the byte of the data when it is received by the 8051 R cross D line. When the bits are received serially via R cross D line, the 8051 deframes it by eliminating the start and stop bits and then placing it into the SBUF register. That means when we want to transmit data, then this data is first stored in or held in the SBUF register and it is framed with the start and stop bits. In case of reception of data or while receiving the data, the whatever data received is stored in again the SBUF register and this stored data contains the start and stop bits. This start bit and stop bit are removed. That means this data is deframed and it is kept into the SBUF register for the further operation. I hope you all understand the basic function of the SBUF register. Okay. Let's see once again. The SBUF register is used to hold the data for transmitting, and similarly whatever the data is received is stored into the SBUF register. This is the general structure of SBUF register. It is 8-bit. Okay. The important note here that SBUF is physically two register. One is write only and is used to hold the data to be transmitted out of via T cross D. Other is read only and holds the data received from the external sources via R cross D. Both mutually exclusive registers uses the address 99H. Okay. I hope you all understand the basic concept about the serial buffer special function register, that means the SBUF register. Now let's see the second type of register named as SCON register. We know that SCON stands for the serial control register. The SCON register is an 8-bit register used to control the data communication. By using SCON register, we can program the start bit, stop bit, and the data bits for the data framing. That means this is the very important register in the serial communication, because by using this register we can program the start bit, stop bit, and we can done the data framing by using this register. This is the general structure of this SCON register. As we can see here that this register is of 8-bit from SCON.0 to SCON.7. The bits are SM0, SM1, SM2, REN, TB8, RB8, TI, RI. Let's see the function of each bit in detail. The first one is SM0 and SM1. The SM0 and SM1 bits are the mode specifier bits, and they are used to determine the forming of data by specifying the number of bits per character and start and stop bits. Okay, that means these are to the mode specifier bits, and depending upon the combination of their bits, the proper mode is selected. For example, if SM0 and SM1 having value 00, then mode 0 is selected. The mode 0 is shift register mode and its baud rate is F divided by 12. If SM0 is equal to 1 and SM0 equal to 0 and SM1 equal to 1, then mode 1 is selected, which is 8-bit UART, and its baud rate is variable. If SM0 is 1 and SM1 is 0, then mode 2 is selected, which is 9-bit UART, and which baud rate is F divided by 64 or F divided by 32. And if both having the values 1, that means SM0 and SM1 is equal to 1, then mode 3rd is selected, which is also 9-bit UART, and its baud rate is variable. Okay, that means the selection of the mode is depends on the bits SM0 and SM1. Let's see the bit SM2. The serial port mode 2 bit, also known as the multiprocessor communication enable bit. That means the SM2 bit is also known as the multiprocessor communication enable bit. When SM2 set, it enables multiprocessor communication in mode 2 and mode 3, eventually mode 1. It should be cleared in mode 0. That means whenever we use the mode 0, that means the shift register, then SM2 should be 0. Okay. The next bit is REN. REN stands for receive enable. When this bit is high, that means when REN is equal to 1, it allows 8051 to receive data on R cross D pin. That means when REN is equal to 1, then we can receive the data from the external source through the R cross D pin. Okay, that means if we want to have both transmit and receive data, that means if we want to use the full feature of the 8051 microcontroller serial port, that means the full duplex mode for the full duplex mode, the REN must be 1. Okay, this is the very important statement here, that for using full duplex mode of 8051 microcontroller, the REN should be equal to 1. If REN equal to 0, then receiving is disabled. I hope you all understand the function of this REN bit. Now the next bit is TB8. Okay, the TB8 stands for transmit bit 8. This is the ninth bit transmitted in mode 2 and mode 3. Since all the registers are 8 bit wide, this bit solves the problem of transmitting the ninth bit in modes 2 and mode 3. It is set to transmit a logic 1 in ninth bit. It is set to 0 in mode 1. That means in mode 2 and mode 3 we require the ninth bit, and this ninth bit is provided by this TB8 bit. Okay, I hope you all understand here. Now the next bit is RB8. The RB8 stands for receive bit 8. This is the ninth bit received in mode 2 and mode 3. If SM equal to 0, RB8 is the stop bit. First 8 bits are the data received, and the ninth bit received will be placed in RB8. It is set to 0 in mode 1. That means both the TB8 and RB8 are set to 0 while using the mode 1. I hope you all understand here. Now the next bit is TI, and TI stands for the transmit interrupt flag. The transmit interrupt flag is automatically set by hardware at the moment the last bit of the byte is sent. That means while if the 8051 microcontroller transmits some data, then after completion of this transmission of data, this TI bit is set. Okay, that means this TI bit becomes 1. It's signal to the processor that the line is available for the next or the new byte transfer. It must be cleared within the software. That means the function of the transmit interrupt flag is very simple, that if the microcontroller transmits some data, then after completion of this transmission, the TI set to 1. Okay, this indicates that the transmission is completed. Now you can send the another byte of data. Okay, the similar function of the receive interrupt flag, that means the RI bit. This is the RI bit. Receive interrupt flag is automatically set by hardware upon byte receive. It signals that byte is received and should be read quickly prior to the being replaced by new data. This bit is also cleared from within the software. That means the 8051 receives the data, then after completion of this reception, the RI flag is set to 1. This is the function of the RI bit. Now let's see the last register, PCON register. We know that PCON stands for the power control register. The PCON or power control register, as the name suggests, it used to control the 8051 microcontroller's power modes and is located at 87H of the SFR memory space. This is the very important register because it is used to control the power saving modes or the power modes of the 8051 microcontroller. It contains two power modes named as power down and idle power mode. Okay, the PCON register is an 8-bit register used for controlling the data rate. It is not bit addressable. That means the PCON register is only the byte addressable register. Okay, the baud rate can be doubled if the SMOD bit is changed from 0 to 1. That means if the SMOD equal to 1, the value of SMOD is equal to 1, then we can double the baud rate. I hope you all understand. Let's see the structure of the PCON register. This is the structure of the PCON register, in which we can see here that the PCON is an 8-bit register. The 8 bits are S mode, PCON.654 are used for or reserved for the future use. The GF1, GF0, PD and idle. Let's see the details about each bit. First one is S mode. It is used to double baud rate bit. The timer 1 is used to generate baud rate and S mode equal to 1. Then the baud rate is double in serial port mode 1, 2 or 3. That means if when we use the timer 1 and S mode equal to 1, then the baud rate is doubled. The PCON.654, these 3 bits are reserved for the future use. Now the next 2 bits are GF0 and GF1. These are the general purpose flag bits. That means we can use these bits for any indication or any flag as per our requirement. The next 2 bits are PD and idle. PD stands for the power down mode bit and IDL stands for idle mode bit. Okay. In PD, this bit activates power down operation in 8051 microcontroller. That means if we want to send the 8051 microcontroller in power down mode, then we can set this bit. Okay. Similarly, if we want to send the 8051 microcontroller in idle mode, then we can set this bit to 1. Okay. I hope you all understand all the bits of the SMOD register and the SBUF and the PCON register. Thank you.